Hello everyone and welcome back to this next lecture. So in the previous lecture we had successfully compiled our project, and in this lecture let us execute it on a microcontroller kit. So this lecture I will be using the Launch XL F28069 and I will bring this microcontroller into the video. So you might be seeing the microcontroller kit in the video, and you will see here that I have removed all the EPWM connections because currently we are not looking at EPWM gating signals, but rather we are looking at the analog signals that we are trying to generate. So for example, I have connected GPIO 12 and GPIO 20 using these jumper cables to two different parts of the solderless breadboard. And in these soldered parts of the solderless breadboard, I have connected resistor capacitor circuits, and these resistor capacitor circuits are in turn connected to resistor divider circuits so that we step down the voltage that is eventually obtained across the electrolytic capacitor. So these connections are just typical regular solderless breadboard connections, nothing special about them. I have used two capacitors, 10 microfarad and 22 microfarad. You are of course free to use any of them. Just make sure whatever you use, the analog signal is appropriate that can be fed to the analog channel. I'll talk about that again soon. So with this done, let me now zoom in on the oscilloscope and let me download the code onto the microcontroller. So the code has been downloaded onto the microcontroller, and I will go and click on the run button. So as you can see, you are now seeing here. Now the connection has been such that channel 1 is measuring the voltage at GPIO 20 and channel 2 is measuring the voltage at the end of the resistor divider circuit connected to the RC circuit which in turn is connected to GPIO 20. So these two are the signals, and finally the blue waveform is the signal that we are going to use as our sample analog signal. So since they are both on the same magnitude, let me just go and superimpose the two waveforms just to give you an idea of the magnitude, and you will see now that they are superimposed, you will see the magnitude of the analog waveform with respect to the digital waveform. So you can very clearly see that the lowest value is well above 0 volts and the maximum value is well below 3.3 volts. And I would encourage you to verify for yourself whatever analog waveform you are generating using whatever value of capacitor is compatible to this. That is, it should be well within this range so that you do not accidentally damage your analog to digital converter. Just for the sake of completeness, I will also measure the other channel. That is, I will also measure what is happening at GPIO 12 and the RC circuit which is connected to GPIO 12. So you see this is the same. Now in this case the sawtooth waveform seems almost like a flat waveform, and the reason for that is because there is a 22 microfarad capacitor connected to it, and therefore the result is at least the ripple is much lower. So this is merely a case of the kind of capacitor you've chosen. I think there are some fluctuations probably because of some loose connections. I will check them out, but in general I hope you got exactly the same results. If you do not, then please post in the Q&A forum and I'll be happy to help you out. So I will end this microcontroller video and I will also exit the debug mode. So as you can very clearly see that we have now managed to produce, using our GPIO pins, analog signals which we can now feed very safely to our analog to digital converter. So if you got exactly the same results, we are now ready to set up our analog to digital converter and then later on feed these signals to analog input pins so that we can read them in our ADC module and then use them accordingly. So again, if any of this did not work, you did not get the waveforms that I got, or you got something very different, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening, and goodbye for now.